Hello, Gretos. Welcome back to this channel. We're still doing fundamental accounting principle, and today we're going to be looking at word arrangements. Word arrangements. So in this lesson, you are going to learn about how to calculate the number of different arrangements of letters that can be made using a certain word. So yeah, we use counting principle also to determine this number of different arrangements in which letters of the word can be arranged. You'll actually see this as we move through this lesson and as we start with these examples. So let us start with this example. Consider the letters of the word dead. So the question says, how many word arrangements can be made with this word if repeated letters are treated as different letters? So it's very simple. They're saying using the letters of the word dead. So we have the letter, the word dead. If we are treating these repeating letters, what are the repeating letters? They mean seminal letters, right? We know there are two Ds. So we are actually treating them as different. So to show that they're different, we can actually write D1 and D2 to show that they are not the same. They're two different Ds in some sense. So they're saying how many word arrangements can be made with this word. If these repeating letters, we are treating them as different, we already indicate that they're different. So we can actually form different arrangements using the letters of that word. And let me actually first show you how we can do this manually, not using the counting principle, so that you may understand when we actually use the calculations of counting principle. So the first arrangement that can be made is, sorry about this. Let me just switch it back. So the first arrangement that can be made is D, A, D, just as it is. So that is the first arrangement that we can make using those letters. So the second arrangement, we can start with A, then we say A, D1, D2. So this is the second arrangement that we can make. So the third arrangement, we can either start with D2 instead of starting with D1. D2, A, D1. Remember, we are treating the letters as different, so there'll be different arrangement. So we have three arrangements. Let's look. Is there another way that we can arrange the letters of the word? Yes, it's possible. If we start with D2 again, then followed by D1, then followed by A. So that's another arrangement that we can make. Another different arrangement, we can start with D1, then followed by D2, then followed by A. Is there another arrangement that we can make using the letters of this word? Let's see. Yes, there's another arrangement. If we start with A, then followed by D2, followed by D1. So it's another different, it's not the same as this one, because here we started with D1 and here we're starting with D2. So it's actually a different arrangement. So I don't think there's another arrangement that we can make. So the total number of arrangements that are there, if we are treating the letters of this word as different, it's 1, 2, 3, 4, 5, 6. So the total number of arrangements are 6 arrangements that we can make. 6 arrangements. You can see that using a manual process itself takes time and it can actually confuse one. So that's how or where the fundamental counting principle enters. Remember, maths is made to make things simple, hence the fundamental counting principle. This principle helps us to calculate this arrangement without actually going and do them manually as we did here, right? So we actually use counting principle to actually determine those total number of arrangements that we need without actually using the manual process, because it takes time. Okay, let's use the fundamental counting principle to answer this question instead of the manual process. So I'll delete all this arrangements, and we will simply use counting principle and to get the answer. Okay, if you want to use counting principle to determine how many different arrangements can be made, you actually count the letters that you want to arrange. So we have 1, 2, 3 letters. So repeating letters are treated as different. We said this is D1 and this is D2. So that's why we're saying you have 1, 2, 3 letters. So the total number of arrangements that can be made, you want to arrange 3 things. Remember factorial notation that we introduced in part 2 of counting principle? I'll drop down the link of that video in the description down below. Just go and check it, factorial notation. If we have 3 things to arrange, using counting principle, the number of different arrangements that we can make is just simply going to be 3 factorial. This is the same as 3 times 2 times 1, which will give us 6 arrangements, just as we got when we used the manual process. So you can see, like, using the counting principle, it's simple to get the answer of the number of arrangements. So let me help you to understand this, rather than memorizing that if I want to arrange 3 things, I'll just say 3 factorials. Where did they get this? Okay, they actually said, okay, because we want to arrange 3 letters, 1 to 3, we're gonna have 3 columns, 1, 2, 3, right? So in the first position, we can either choose how many options do we have. So remember, counting principle deals with options, right? Number of choices that you have in a particular situation. In the first option, we can either put D1, we can either put A, we can either put D2. So how many choices do you have? You have 3 choices. Okay, let's go to the second position. Now that the first choices has been filled, obviously it's gonna be filled with one of those 3 options. So what we know is that the first option, the first space has been filled with 1 letter. It means we can actually cancel any letter we may like. So maybe we had chosen D2 in the first option, right? So how many choices will you have in the second position? You'll be left with 2 choices. Then you just cancel another one. Then how many choices you are left? You are only left with 1 choice. So the total number of different arrangements using counting principle that these letters can be arranged is actually the multiplication of those options that you have. So it's basically the same as 3 factorial, which is 6. I hope that made sense. Remember, when repeating letters are treated as different. Okay, let us look at number B. Now it's sort of like a different approach. They're saying how many word arrangement can be made with this word if repeated letters are now treated as identical. So it's different from the first one, right? So they're saying the letters of the word dead. Now we are saying what you see, you do it as you see it. We know that these are repeating. So we are actually treating them as identical, just as how we see it. We see that the D's are repeating, so they're identical, right? How many arrangements can be made? I'll first also use the manual process to show you how many different arrangements that we can make, right? So using the manual process, the D's are identical. They didn't say, let us use the repeating letter as different. It's a different case, this one. They're saying repeating letters are treated as identical. So we do it as we see it, right? So how many arrangements can be made? So the first arrangement can be like just how the word is written, dead. This is the first arrangement to it. The letters of the word can be arranged. So the second arrangement, we can start with A, then those D's. Right? So another arrangement, we can actually start with the D's, then followed by A. It seems as if there's no any other different arrangement can be made if we are using repeated letters as identical. So in total, we have 3 arrangements that can be made. 3 different arrangements that we can make. So we use the manual process. So let's now use the fundamental counting principle to actually calculate these arrangements. Okay, you must take note. If they tell you that repeated letters are treated as identical, you solve it as it is. So how many choices do you have? So you have 1, 2, 3. 3 choices of the letters, right? So it's going to be 3 factorial. But then it's not the answer, because we have repeating letters. So every time when repeated letters are treated as identical, or as how we see it, you actually divide with the factorial notation of those repeating letters. Why do we do that? We want to cancel out the effect of repeating letters so that we may be left out with the number of different arrangements. Remember, different arrangements that we can make using this letter. So because we have repeating letters and they're treated as identical, we're going to divide by the factorial notation of those repeating letters. Because we have these that are repeating twice, we're going to divide by 2 factorial. So this will be 3 factorial is 3 times 2 times 1 divided by 2 factorial is 2 times 1. 2 times 1 will cancel out with 2 times 1. Then we'll be left with 3 arrangements that we can make. So you can see, using fundamental counting principle, it becomes easier rather than going and do it manually. So let me just repeat this again. If repeated letters are treated as identical, in order to determine the total number of different arrangements that we can make, you actually count how many letters are to be arranged. 1, 2, 3. It's going to be 3 factorial, right? But then because repeated letters are treated as identical, we have to cancel out the effect of those repeating letters. So you'll actually count how many repeating letters are there. There are these repeating twice. So we'll divide by 2 factorial to cancel out the effect of those repeating letters on those total arrangements, so that we may be left with the total number of different arrangements that we can make if repeating letters are treated as identical. I hope that makes sense. Let us now move to other deeper examples. So consider the letters of the word needed. A, how many word arrangements can be made if the word, with this word, if the repeated letters are treated as different? Okay, we're just gonna use counting principle. We won't do the manual process. Let's just use counting principle because it makes things easier. Hence, this lesson is counting principle, word arrangements. So consider the letters of the word needed. How many word arrangements can be made with this word if repeated letters are treated as different letters? So all repeating letters, we are treating them as different. Okay, so the word needed now, it's going to be NE. Let's just use E1 to show that they're different. E2, then D1, E3, then D2, needed. So I'm actually using those numbers to show that those letters are different, right? How many arrangements can be made? If you remember the factorial notation lesson in part 2, we actually show you how to use counting principle to determine the total number of different arrangements if we're arranging different objects. So all these now are different. So in order to calculate how many different arrangements can be made, you just count how many letters you are to arrange, then you put factorial. You get the number of different arrangements. So how many letters? 1, 2, 3, 4, 5, 6. So the total number of different arrangements will be 6 factorial. So we'll use the calculator to get the answer of that. 6 factorial in your calculator will give you 720 arrangements that can be made. Arrangements that we can make for this letter. Okay. B, we're still on the same word needed. How many word arrangements can be made with this word if repeated letters are treated as identical? So those repeating letters, we are treating them as they are, identical. Needed. Okay, so we are treating repeating letters as identical. How do we approach this? It's simple. We actually count how many letters we are to arrange. 1, 2, 3, 4, 5, 6. So it will be 6 factorial. But because the repeating letters are treated as identical, we have to divide by the factorial number of those repeating letters. Why? To cancel out the effect of the repeating letters, so we may have arrangements that are different. Okay, So it will be 6 factorial. Then we're going to check. Repeating letters are treated as identical. We have to remove them, right? Because they are being treated as identical. We have the E's. E's are repeating how many times? 1, 2, 3. So we'll divide by 3 factorial. It's not only E that is repeating. There is also D. How many times is it repeating? 1, 2. We're going to also divide by 2 factorial. So it will be 6 factorial divided by 3 factorial times 2 factorial. So we're going to use the calculator to get the answer of that. So using my calculator, it gives me 60 arrangements. 60 arrangements that can be made. 60 arrangements. I hope that makes sense. Let me just repeat this. If repeating letters are treated as identical, you actually count how many letters are there to arrange. 1, 2, 3, 4, 5, 6, 6 factorial. You check. Because repeating letters are treated as identical or similar, you actually have to remove them by dividing by the factorial notation of them. So it's E repeating 3 times, we divide by 3 factorial. It's D repeating twice, we divide by times 2 factorial. So that's how we do it. C. How many word arrangements can be made with this word if the word starts and ends with the same letter? This is now a different and actually interesting but challenging restriction. So they're saying how many word arrangements can be made with this word if the word starts and ends with the same letter. So the word is starting and it's ending with the same letter. How many arrangements can be made? Okay, how is this possible? Because it's the letter of the word needed. In order for it to start and end with the same letter, okay, we have 5. It's 6 letters. 1, 2, 3, 4, 5, 6. For it to start and end with the same letter, it's either it starts with E so that it may end with E because we have E's repeating, or 1, 2, 3, 4, 5, 6. It can either start with G and end with D. That's it. So it's either start with E, ending with E, or start with D or end with D. So the total number of arrangements, we're going to calculate the number of arrangements that can be made this side, including the number of arrangements that we can make this side. Then we add them. Then we get the total number of arrangements. Because they say it must start with the same letter, ending with the same letter. Okay. Let's do this. Okay, for it to start with E, remember, in this case, they didn't say repeating letters are treated as different, right? It means that repeating letters, we are treating them as identical, as how we are seeing it, because there's no restriction to say repeating letters are treated as different. So you treat repeating letters as identical, as how you see it, and all the restrictions that you make are those restrictions for when repeating letters are treated as identical. Don't forget that. Okay, if it must start with E and end with E, for it to start with E, how many choices do you have in the first position? You only have one choice. It must start with E. So that one is restricted like that. It's only one choice. You have to choose E. So you have one choice. Remember, in counting principle, we include the number of choices that we have. If it must also end with E, how many choices do you have of the letters? You only have one choice. You must choose E, right? So that's it. So now let's go to the middle. Now that you have used your 2 E's, you see the E's have been used, 2 of them, right? How many letters of the word are you left with? Okay, let me just write the word needed here so that it may make sense. Needed. Now you have used your 2 E's. They are gone, right? How many choices do you have now? You have 1, 2, 3, 4 choices, right? So it will be, oh, sorry about that. So you have 4 choices, 4 words left that you can choose from. So it will be 4 factorial. But remember, there are some repeating letters. The D's are what? Are repeating. You have to divide by the factorial of the repeating letters. So the total number of arrangements that we can make when we start with the E and end with E, remember there is multiply by 1 this side, multiply by 1. So it's going to be 1 multiplied by, in the middle, you remove the E's, you check the remaining letters. N, D, E, D. So it's 1, 2, 3, 4. Hence you are saying 4 factorial, but we know that these are repeating. We divide by the factorial. So that's the total number of arrangements that we can make this side if we are starting with E. Okay, I hope that makes sense. Let's go with D. In order for it to start with D, how many choices of D do you have? Like in the first position, it must be D. So you only have one choice. It must be D. So you only have one option. You have to choose D. So in the last option, it must end with D. So you also have one option. It must end with D, right? So let's come in the middle here to see how many arrangements can be made. So we're still using the letters of the word needed. So now the D's have been used. Let's cancel them out. We can no longer use them again. The D's have been used. We are left with how many words to arrange? Letters to arrange. 1, 2, 3, 4. So it will be 4 factorial. But remember, don't forget to cancel as the repeating letters. The E's are repeating. How many times? 3 times. We have to divide by 3 factorial. So the total number of arrangement in this case will just be simply be, remember, times 1 for this side, times 1 from that side. So those are the total number of arrangements that we can make if we're starting with D and ending with D. So the total number of arrangement that this word can be made if it's start and end with the same letter, we're going to get the answer this side, we add it with the answer this side. Then we'd get the total number of arrangements that can be made if the letter starts and end with the same, if the word start and end with the same letter. So it will be 1 times 4 factorial using a calculator, divide by 2 factorial, multiply by 1. This side will have 12 arrangements that we can make. There are 12 arrangements. Let's go that side. It's 1 times 4 factorial, divide by 3 factorial, multiply by 1. So this side we only have 4 arrangements that we can make. So what is the total number of arrangements that can be made? So let me just use a different color to show that this is the answer. So the total number of arrangements that we can make, total, it will be 12 plus 4, which is 16 different arrangements that we can make. So there are in total 16 different arrangements that can be made if the letters of this word must start and end with the same letter. So yeah, I hope that makes sense. Let's just move to another example. Consider the letters of the word need. Is it night? Yeah, consider the letters of the word night. Is it? Do we say knight or night? Just any pronunciation, but yeah, consider the letters of the word night. I'll just say night or knight. Knight. Okay, maybe case is silent. Night, yeah. How many word arrangements can be made with this word? Letters are not repeated. Repeating letters are not written as being repeated. Wait. How many word arrangements can be made with this word if letters are not repeated? Okay, now it's a different restriction. They are saying letters must not be repeated. How many words arrangements can you make if letters must not be repeated? Okay. How many choices do we have? 1, 2, 3, 4, 5, 6. So the total number of arrangement would just be 6 factorial. This is the same as 6 times 5 times 4 times 3 times 2 times 1. Just use a calculator to get the answer of that. 6 factorial to give us 720. arrangements that can be made. 720 arrangements that we can make. Okay, let's now move to another example. Okay, actually, I feel like explaining what this means. Letters are not repeated, right? So what does it mean? It means that if you use a letter, you must not repeat it again and use it in another position. Hence, you are saying 6 factorial. So you can actually think about this in this way. Someone can approach it this way: 1, 2, 3, 4, 5, 6. To say, okay, because I have 6 letters, I must have 6 spaces, right? In the first position, I can either choose K, N, I, G, T, H, T. So I have 6 choices, right? Let's move to the second position. Now the first position has been filled with 1 letter. This is just the number of choices I have, right? But I'm going to have, this is just the number of choices I have. But I'm going to have 1 letter in that position. It means I will cancel 1 letter. How many options will I be left with? It means from 6 letters, I remove 1. I'm left with 5 choices. Now 2 spaces are filled with the letters. From my 6 letters, I remove 2 letters. How many letters are left? 4. Like that. How many letters? 3. Like that. 2. Like that. 1. It is basically 6 factorial. So that's how they got that 720 arrangements. B. How many word arrangements can be made with this word if the word starts with K and ends with T? If the word starts with K and ends with T. Remember, because we have 6 letters, we must have 6 positions or spaces. 1, 2, 3, 4, 5, 6. It must start with K. It must end with T. So those are the fixed positions. We call them fixed positions. There is nothing else that must sit there. It must start with K and it must end with what? With T. So the letter was night. So 1, 2, 3, 4, 5, 6. Yeah. So if it has to start with K, how many choices do you have in the first position? It's only 1 choice. Remember counting principle? Always. This is a trick. Or no, not actually a trick. This is a skill that you must have in counting principle, right? Always think of the number of choices you have in a particular situation. That's how counting principle is all about. If you always think about the number of choices you have in a particular situation, then you get the answer. So many people become confused when they start to think about other things. So always think about the number of choices that I have in a particular situation. That's counting principle. Apply the rule, get the answer, get the marks. So if it must start with K, I only have how many choices? 1 choice. If it must end with T, how many choices do I have? It's only also 1 choice, right? So those ones are fine now. Now K has been used, T has been used, right? K has been used, T has been used, right? So you're left with how many words? 1, 2, 3, 4. You're left with 4 words that you can choose from, right? You can choose from 4 words. How many arrangements can be made with those 4 words? 4 letters. It will be 4 factorial. So let me just write 4 factorial in the middle. So those 4 letters can be arranged in 4 factorial ways. So the total number of arrangements that can be made, you simply multiply those options. 1 times 4 factorial times 1. There will be 24 arrangements that can be made. 24 arrangements that we can make. Okay, I hope that makes sense. I think this is the end of our lesson. This was word arrangement. Tomorrow we'll be focusing on number, that is digits, passwords, and PIN codes actually. how you can actually arrange those in actually different ways using counting principle. Thank you very much for your time. Enjoy the rest of your day. Thank you.